of even the intelligence or level of understanding of the world of a cat or a dog, which doesn't have language. They don't have language, and they understand the world much better than any LLM. They can plan really complex actions and sort of imagine the result of a bunch of actions. How do we get machines to learn that before we combine that with language? Obviously, if we combine this with language, this is going to be a winner. But before that, we have to focus on how do we get systems to learn how the world works.
So this kind of joint embedding predictive architecture, for you, that's going to be able to learn something like common sense, something like what a cat uses to predict how to mess with its owner most optimally by knocking over a thing.
That's the hope. In fact, the techniques we're using are non-contrastive. So not only is the architecture non-generative, the learning procedures we're using are non-contrastive. So we have two sets of techniques. One set is based on distillation, and there's a number of methods that use this principle. One by DeepMind called BYOL, a couple by FAIR, one called VicReg, and another one called IJEPA. And VicReg, I should say, is not a distillation method, actually, but IJEPA and BYOL certainly are. And there's another one also called Dino or Dino, also produced from at FAIR. And the idea of those things is that you take the full input, let's say an image, you run it through an encoder, produces a representation, and then you corrupt that input or transform it, run it through essentially what amounts to the same encoder with some minor differences. And then train a predictor. Sometimes the predictor is very simple, sometimes doesn't exist, but train a predictor to predict a representation of the first uncorrupted input from the corrupted input. But you only train the second branch. You only train the part of the network that is fed with the corrupted input. The other network you don't train, but since they share the same weight, when you modify the first one, it also modifies the second one. And with various tricks, you can prevent the system from collapsing with the collapse of the type I was explaining before, where the system basically ignores the input. So that works very well. The technique the two techniques we've developed at FAIR, Dino and IJEPA, work really well for that.
So what kind of data are we talking about here?
So there's several scenarios. One scenario is you take an image